All right, sorry, awkward edit point there. Let's go ahead and try some problems. Let's go ahead and try number 2. All right, number 2 says, whoops, y equals the integral from 2 to x. Sorry, y equals the integral from 2 to x. 3t plus cosine t squared. 3t plus cosine t squared dt. All right, and then the problem says that we're not finding this integral. It says find dy dt. dy dt. dy dt. dy dx. Goodness, I can't read or write. There we go. dy dx. Let's find the derivative. Basically, it's saying invoke part 1 of the fundamental theorem. When you take the derivative of an integral, it's just that function, and it doesn't matter where you start. So the derivative is 3x plus cosine x squared. That's it. Just asking you to recall that property. Let's look at one that's a little bit different in the same section, number 18. The integral, number 18. Y equals the integral from 3x squared to 10 of the natural log of 2 plus p squared, natural log 2 plus p squared dp. Remember, this variable inside here is a dummy variable. This doesn't matter. Okay, that is going to go away. So they could use they use t above, you could x, you could use whatever. So now it's again saying find the derivative, find dy dx. Well, the first thing I need to do is change this around a little bit so it looks more like my function there. So let me see what I can do with this. First thing I would do is I want to switch these around. So when I switch around the limits of integration, it makes it negative. Negative from 10 to 3x squared, natural log 2 plus p squared dp. Okay? I need to do something else as well, because this only works if this up here, it can't be x squared. It's got to be just an x. So what I'm going to do is I'm going to do a substitution. I'm going to invoke the chain rule, if you can believe that. So what I'm going to say is that some other variable, and we usually use u for that other variable, u equals 3x squared. And the chain rule is going to look like this. Instead of saying, I'm going to say dy dx is equal to dy du times du dx. And this doesn't look like how we usually write the chain rule. We usually write it differently. But it's basically saying the same thing. Just take the derivative and copy whatever the u is. Just take that and consider that x. And then multiply by the derivative of what you copied, the derivative of u. Okay, so let's go ahead and do that over here. Let's see what happens. First thing I'm going to rewrite this one more time. Goodness gracious, all this rewriting. From 10 to u. The natural log 2 plus p squared dp. Okay, well, I've substituted that in. I haven't taken the derivative yet, so I'm not going to invoke the chain rule just yet. Okay, now that I have this set up, now that this is a nice, just a single variable up there, now I'm going to apply the chain rule. I'm going to find the derivative. dy dx. Okay, well, what is this going to be here? This is going to be natural log. Whoop, negative. I knew I was forgetting something. Negative natural log 2 plus u squared times, so this was dy du, got rid of that, times du dx, times the derivative of u. Now go ahead and just write u prime for a second here. And then I will make a substitution. So u prime, the derivative of u, is just 6x. Okay, so I really should have written du dx. There are too many variables floating around, but oh well. So let's go ahead and substitute in our value of u for x, and that will give me my final answer. dy dx is equal to negative natural log 2 plus u squared. Well, what's 3x squared? 3x squared times 3x squared is 9x to the fourth times u prime times 6x. Okay, and I may be able to simplify that a little bit more, I guess just put the 6x out front or something like that. But basically that's it. That's my derivative. Let me double check my answer in the answer book. It's always a good idea to look in the back. Negative 6x natural log 2 plus 9. So yeah, the answer in the back, just move the 6x over. Beautiful.